So let's imagine that you just finished your first physics class in college and you're approached by an amusement park and they say that they want you to make one of those rides where there's like this little cylinder and the people are spinning like this and there's this floor and eventually the floor drops away and you have to be suspended there, okay? And they give you some specs, right? They don't put you completely in the dark. They tell you that the velocity, that the maximum velocity that this cylinder can spin and the people who are riding don't all want to puke is about v equals 6 meters per second, okay? And they also tell you that the radius of the cylinder is about 3 meters, okay? Now, the question is, they're like, we have to tell our materials people what to make these walls out of, right? Because we need to know what must be the minimum coefficient of friction on these walls to keep this person suspended when it's spinning at this speed. All right, very interesting question. Now, because you took this physics class, you are completely prepared to answer this question. First, you say, we gotta make a free body diagram here. And your physics teacher would be very proud. And the physics teacher would say, well, what exactly do you want to, what forces are acting on this person, right? And so you would say, well, obviously the person has a weight, right? Obviously, something's got to be supporting this rider against the weight, which is going to have to be the frictional force, specifically static friction, right? Because it's not sliding up and down. And obviously, there has to be some centripetal force, something causing the centripetal force, something keeping this rider moving in a circle. Now, the only thing that could possibly be keeping this rider in a circle is the wall, right? The fact that they're pressed up against this wall, which means there is a normal force pointing inward, right? And that normal force must be the centripetal force, okay? So we do our classic Newton's law analysis. We say sum of forces in y must equal MAY, right? And we look at here, we see there's a positive Fs in y, and there's a negative weight, so Fs minus W must equal, now again, this rider isn't falling through the floor, and they're not rising up in the sky, so that must equal 0. Okay, all right, and so if we just take this a little bit farther, we can see that the frictional force, the static friction must equal the weight, and we also know that the static friction is equal to mu times n. And we know that weight is equal to mass times gravity. Okay, now we're getting somewhere, right? Now we know that if we can somehow solve this equation for mu, right, then we can actually get our answer. All right, question is, we don't know mass, and we don't know what n is. How do we get it? Well, we're not done doing our Newton's law analysis. We also have a sum of forces in x, right? Sum of forces in x is equal to ma x, right? Now there's only one force in the x direction, that's n, and because this is circular motion, our ax is v squared over r, centripetal acceleration, okay? Now we have an n. All right, this is very, very helpful. I'm gonna substitute this n over here into this equation. I'm gonna do it over here inside this little cylinder. So that means that mu times mv squared over r, right? I'm just subbing this in for this n over here, must equal mass times gravity. All right, and immediately I see that there's an m on each side, so satisfying. I'm gonna go ahead and cancel those out. And that means that mu v squared over r equals g, right? What are we looking for? Again, we're trying to find the coefficient of friction, so we gotta solve this for mu. If I just do a little bit of algebra, I see that mu equals rg over v squared. All right, very cool. Now we have something, right? Do we have all these variables? Can we substitute now? Totally. We have everything we need. Let's do it right here. So mu equals r is 3, g G is gravity, 9.8. And V, the velocity at which this cylinder is turning, is 6 meters per second. So that's 6 squared on the bottom. And if I put all that in my calculator, I get a coefficient of friction of 0.82. All right, one semester of physics, and you're able to solve this question for this amusement park. They need to talk to their materials people and find out what is some material at which I can get a minimum of a 0.82 coefficient of friction so that these riders are actually able to be supported on the wall and don't fall to their deaths as the ride comes to an end.